Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 1,2-dimethylcyclohex, 2-Na, or equivalently described as a cyclohexene ring where C1 and C2 both bear methyl substituents and share the endocyclic double bond. This makes the double bond trisubstituted. 2 ring carbons plus 2 methyl groups contribute substitution. Moving on to the next step. MCPBA is a peracid that performs electrophilic epoxidation of alkenes. It epoxidizes the more electron-rich, more substituted, double bond preferentially. The reaction is a concerted SYN addition of an oxygen atom across the double bond, converting C is equal to C into a 3-membered cyclic ether, epoxide, with retention of stereochemistry. Moving on to the next step. The starting material has one double bond. The endocyclic C1 is equal to C2 double bond with methyl groups on both carbons. MCPBA epoxidizes this trisubstituted alkene to give the corresponding epoxide. And for the final step, epoxidation of the 1,2-dimethylcyclohex, 2-Na double bond gives a bicyclic product, a cyclohexane ring fused with an epoxide, oxirane, ring at the 1,2 position, with methyl groups on both epoxide carbons, 1 methyl on each of C1 and C2. This matches option B, which shows a cyclohexane ring with an epoxide bridge and methyl groups, gem or vicinal, on the epoxide carbons. Option A shows epoxidation at a different, less substituted or exocyclic position with retention of the endocyclic alkene, which is not preferred. Option C shows an allylic alcohol, which would result from a different reaction mechanism, not MCPBA epoxidation. Option D shows an allylic alcohol product, again inconsistent with MCPBA epoxidation. MCPBA epoxidizes the more substituted endocyclic double bond of 1,2-dimethylcyclohex, 2-Na to give the 1,2-epoxide product shown in option B. Therefore, the correct answer is B. Therefore, the correct answer is option B.